Hello everybody, so today I will explain this LeetCode hard question. Couples holding hands. So in this question, there are n couples sitting in two and seat, arranged in a row, and one hold hands. The people in seat are represented by an integer array row, where row I is the ID of the person sitting in the ith seat. The couples are numbered in order, the first couple being 0, 1, the second couple being 2, 3, and so on, with the last couple being 2n minus 2 and 2n minus 1. Returns the minimum number of swaps so that every couple is sitting side by side. A swap consists of choosing any two people, then they stand up and switch seats. Choosing two people, then they stand up and switch seats. Okay. So in this question, I'm giving an array, something looks like this 0, 2, 1, 3. And each element in this array is a person's number. And in this question, person number 0 is a couple with person number 1, and person number 2 is couple with 3, 4 is number is 5 if he is in the list. Yeah. But anyway, so this is the rule. This is the couples. And in this question, I swap two people like this and this. And after swapping, people looks like this. And now, people number 3 and 2, they're a couple. They're sitting side by side. And person number 1 and 0, they're a couple sitting side by side. So every couple is sitting side by side, so the condition is met. So I swapped only once. So I return 1 because I have to swap at least once, and I could swap with only one time. So definitely swap only one time is the minimum number of swaps I can make to meet the condition. Okay, so this is the definition of this question. Obviously, for this case, I have another way, like this. If I swap this person and this person, it looks like this. And person 0 and 1 are sitting side by side. This couple is sitting side by side. So this is met. So I swapped only once. So yeah, this is also another case I can make the each couple sitting side by side only with one swap. And in this question, I will find out the minimum number of swaps and return it. Okay. Now, let me think how I can solve this question, but let me give you one more example, maybe a bit longer. Like this. So when I think of this case, wait a minute. The first thing I can say is this person, index 0, and this index 1 should be a couple. Should be dating. Because, so, and also I can say index 2 and 3, they should be couple. Index, wait a minute, 4 and 5, they should be couple. What I want to say is, if they're couple, yes, it's okay for this couple. But there is at least one person here which cannot make, who cannot sit side by side with his, couple, boyfriend or girlfriend. So, taking the seat in this way doesn't work. So that's why I can say one couple should sit 0 and 1, the second should sit index 2 and 3, blah, blah, blah. Okay, so this is the observation I can make. So let's call it throat. Yep. So in this way, I can think of it like this. So this is a throat, this is a throat, and this is a throat. Okay. And my task here is somehow I want this to 0 and 1, or because 4 is a couple with 5, so 5 and 4. So I somehow would like to make it in this way. Of course, it is possible that I can put people like 0, 1, oh, yeah, 0, 1, 2, 3, 4, 5 in order, or maybe I can put some people like 3, 2, and 3 here, but it isn't, optimized way. The optimized way is I can make this person 1 a couple with some other person. I mean, I should keep this person or maybe this person in this position, in this slot, and swap only one person in these two people. Yeah. So that's something I can say to optimize, I mean, swap people in an optimized way. Okay. So how can I swap people and optimally make each couple sitting side by side? So I will show it in with this example. So let me add one more people here to make it interesting. 6 and 7. Okay. So here, 1 and 4, they're not a couple, so I have to swap one people. Actually, it doesn't matter which person I swap, but then let's say I swap this person. And when I swap this person, I would think, who should come here? Person 0, because person 0 and person 1 are couple. So I take this person, yeah, to here. So after swapping, after the first swap, it looks like this. And here 3 and 4. Okay. And from here, because I swap this and this, maybe you think, okay, so next let's swap from this couple, swap someone from this couple, and make this slot valid. But actually, it isn't an optimized way. Optimized approach. After swapping this person, this couple, I should make this couple satisfy the condition. But actually, in this case, it already. No. Yeah, I have to do that. So then, when I take a look at this couple, I find that person 3 should be a couple with person 2. Yeah. So this person should be popped out. And person 2 should come here. So this person should be swapped with. So that being said, what happens is here, person 4 should come here. It doesn't matter. It doesn't change for 6 and 7. And it should be 3 and 2. So now I can say 4 and 5. I mean, I can say I swap people from this couple and from this couple. And now, as I said, I have to take a look at this couple. Yeah. So I was looking at this couple and I swapped with this couple, someone from this couple. So next I should take a look at this couple. But here, 4 and 5, they're in a couple. I don't have to make swap anymore. Yeah. So I can say it's done for this couple. So next, so what I can say here is I took a look at this couple, then this couple, then this couple. Yeah. But I have remaining couple, remaining thread, which haven't confirmed yet. So I take a look at, you know, that. So basic idea is that I do the for loop from here and then move below like this. Let me write it down. So actually this kind of loop, for loop, is a bit like the number of irons. So I start from this, and from each index, I make the swap. So when I'm at here, as I did, I swapped this person with this person. Then I swapped this person 3 with this person 5. No, person 2. So I swapped in this way. Then, oh, that was it. Okay. So I swapped this and this, then this and this. And after that, this became the couple that don't have to continue anymore. So now I move this pointer and I start from here. But as I said, this is already met. They're couple already. I keep going. And here, 6 and 7 are in a couple. So I can keep going. And this too. So yeah, I end the iteration. So basically, I move the index in the auto iteration. And if I find a thread which is not occupied by a couple, then I start the swapping. So, and I keep swapping like the chain until the last thread in the chain becomes a couple. Then after that, I come back here and I move the index in the outer loop and I keep going. And if I find a thread which is not occupied by a couple, I start the swapping chain again. So this is the basic algorithm I can use. Okay, that being said, I start the implementation. So but let me quickly sort out the idea. So the first thing I have to do is make the list of threads in this way. Oh, no. In this way. This makes the implementation much easier, so I will do that. Then I use the for loop. And as I said, if already occupied by couple, continue. Otherwise, start swapping chain from here. And every time I make the swap, increment the total count. Yeah. And then after the swapping chain is done, from this thread, I come back to line 37 and I, move the index in the auto for loop. Okay. And then in the end, I return total count. So this is the basic idea of how I can implement this question. Okay, so now I really get started with the implementation. Okay, so first thing I would do is this rot. Like this. And after that, I take a look at each slot. No. Yeah. Then I take a look at the person in this slot. Yes. And here, and I'd like to know which position I'm at. No. So this is the slot index, and this is the slot. Oh, let me change it a little bit. So this is the slot index. So slot index, and I get the person 1 and the person 2. And I have to check if they're a couple. So if there's a couple, I continue. I need this function. Otherwise, I start the swapping chain. So, and it doesn't matter which person I choose, I should swap. So let's swap P2. In this case, with a pair person, pair with P1. Yeah. So I can say P1 pair I get the P1 pair, and I swap this P2 with this P1 pair person. And now I have to know in which slot this person is. So I will create the mapping for that. So mapping means person ID to slot ID. In this way, I can know where this P1 pair person is in all the slots. So let's say so there are 2 people in each slot. And yeah, I can't implement it in line. So person to slot index. So here I can say P1 should be pointing to the slot index. Wait, have to enumerate. So this P1 person is slot index here, and same for person 2. Okay, so now I've created slots, which is the list of list, and person to slot index, which is a hash map. Here I can say, so destination slot index is this. So what I would do is I swap this person 2 with people in this slot. So I can say, maybe I don't need it. It just, yeah, so it's okay. Yeah, anyway. So in this destination, there's 2 people like this. So yeah. So I can say each of them is actually P1 pair. So if P3 is P1 pair, so let's say I'd like to make this P3 to be the pair of P1. So if P4 is the pair person, I swap. In this way here, I can say P3 is P1 pair. So I can say original price here, this should be now P1 and P1 pair, which is P3. And for the destination slot, this should be now P P3 swapped, so P2 should come here and P4 here, right? Yep, looks good. Okay, so this is it. So from here, I have to do the same thing from, line 55. I mean, I have to keep swapping for this couple, makes the swap for this couple to be side by side. Oh, sorry. I have to keep doing the swapping and so that this slot is occupied by a couple. So what I have to do is keep doing this with for loop or maybe while loop. So let's do it in this way. So okay. And here, so let's say current index is index. And I take a look at this index here. And actually I can take a look at it inside of this while loop. So I, update this current index after this while loop in this way. And basically, the thing is that, so I take a look at the current index, and there are 2 people here. And if they're a couple, then I break. I don't have to do it anymore. But if not, I make the swapping with the next destination slot index. Let me change a bit. Slot index. And then let me rename this to next slot index. Yep. So in this way, I make the swap with people from current index and people from next slot. And then I take a look at the next slot index as the current slot index in the next loop. Okay. So basically, this is something I should do here. I did here. But also, if I do this, I also have to update the hash map person to thread. So let me do that. Here, P3 should point to index. No. Okay, and also for people P2, P2 should be pointing to the next thread index. No. Hmm? Yeah, right. So this is something I have to do. Yeah. And as I said, now I've done with the, swapping chain, this part. And also as I've written in line 40, I have to keep track of the total count. So I start from 0, and every time I'm at here, I update total index. Yeah. So basically this is it. Okay. Actually, I'm thinking that I can make it here. So like is coupled. This is the checker method. Oh, I see. Yeah. And I take a look at this person, current thread index. And if there's a couple, I break. No. So yeah. So if they're not the couple, I continue. But if they're a couple, I finish here. Okay. And because I pass the thread here, I can say thread. Good. So now my remaining task is to implement this, helper methods. Okay. So for 2 threads, so yeah. They're n couples. So for each couple, they located at 2 times I and also 2 times I plus 1. So I append these people to this thread, or as you can say, P1, P2 is in, I can find it in this way. So thread is P1 and P2. So in the end, I should return the threads. So I append this thread to this returned array. Okay. And our couple here, this is thread. So P1, P2 are people in this thread. And I can say, so P1. So I can say, so let's say if P1 is larger than P2, I swap them. So in this way, here, I can say this. And the condition to check if they're a couple or not is if they meet something like this. So I have 2 things to check here. The first thing is P1 is an even number. Also, I have to confirm that P1 plus 1 is equal to P2. If they're met, I can say P1 and P2 are a couple. Okay, so I think I've done with the implementation, so let me submit. Uh, total index, total count. And I should return total count in the end of the main method. Okay. Solution object has not repeated per person. I see. So I wanted to return the per person. So yep, I can think of this in the same way. So if this person is an even number, the pair is p plus 1. But this is odd. If this is odd, I should decrement by 1. Or just say, I subtract 1 from this person index and return it. Okay, this is it. So let me submit again. So P3 is equal to P1 pair. This is not true now. So I will debug this. So oh wait. I think I haven't initiated P1 and P2 here. I think this is these variables are pointing to this one. So here what I have to do is P1, P2 is this. And I initiate this P1, P2 here in this while loop, and I keep going. Okay. Good, accepted. Okay, accepted. So I've done with the implementation. Okay, so for time complexity, I basically start from each index. So the auto for loop takes O of n time, assuming that there are n couples. And for the, swapping chain, I can start from somewhere, but this keeps going on the thread, which is not occupied by a couple yet. So each thread is visited only once in any of the swapping chains. And when it goes through, when the swapping chain goes through some thread, after that, that thread is occupied by the couple. So that thread will never be visited by the swapping chain. So with that swapping chain, the total length of the swapping chains could be up to O of n. So in total, it takes O of n time. Okay, for space complexity, so I need the person to thread index. Oh, I actually started from thread list, which takes O of n space. Person to thread index, this hash map can take O of n space. And aside from that, basically this is it. So in total, it takes all of n space complexity. Okay, yeah. So that being said, I finished my today's um, explanation of this question. I actually didn't tell you why this approach, swapping chain approach, is an optimal way. So, but yeah, let me talk about it maybe in the future videos. So please request if it's something you'd really want to know. Yeah, and also actually this one is called the cycle sort. So this is a kind of keyword you can search on the internet with. So yeah. Okay. That being said, I finished my today's video. Thank you so much. Bye.